Hello everyone and welcome to my channel. So in today's question, we have to compare various oxoacids of phosphorus, their oxidation state and the number of acidic hydrogens. So before we solve this question, I want you to make a note of certain things regarding the oxoacids of phosphorus. So here you can see a few important oxoacids of phosphorus that I have enlisted. So amongst these oxoacids of phosphorus, the first category is the category of the phosphorus acid, right? And the phosphorus acid, we have three major acids: the hypophosphorus acid, phosphorus acid, and the pyrophosphorus acid. So what is the distinguishing feature in the phosphorus acid category? The distinguishing feature is the phosphorus acids have +1 or +3 oxidation states. And also these have a pH bond, that is phosphorus hydrogen bond. Next is the category of phosphoric acids. So here are the 5 phosphoric acids that I have written, and the distinguishing feature of these phosphoric acids is the presence of +4 or +5 oxidation states, and also the presence of P double bond O and POH bonds. Okay. And also you can take a note of the prefixes that are attached to these phosphorus and phosphoric acids. The prefixes have some sense, okay? Like the orthophosphoric acid. Here we have the prefix ortho. So you can see various prefixes for these oxoacids: hypo, then pyro, then again hypo for both phosphorus and phosphoric acids, pyro for both phosphorus and phosphoric acids, then ortho, and metaphosphoric or phosphorus acids. So all of these prefixes, ortho, meta, pyro, hypo, so these have certain specific meanings. And these prefixes, what do these prefixes denote? These prefixes denote the degree of hydration, okay, and the oxidation state of the oxoacids. And among these, the orthophosphoric acid is the parent acid. Why parent acid? Because this is the highly hydrated form of the oxoacids of phosphorus. And since orthophosphoric acid is the parent acid because it is the highly hydrated form of the acid, so rest of the oxoacids of phosphorus are derived from orthophosphoric acid by the removal of water molecules. Okay, if one water molecule removed, then we have a prefix. If more than one water molecule removed, then we have different prefix. If the removal of water molecule is through heat or through other resources, then we have a different prefix. So rest of the oxoacids of phosphorus are formed by the dehydration of orthophosphoric acid. So broadly, the oxoacids of phosphorus are divided into two categories: phosphorus and phosphoric acids. Phosphorus acids, they have +1 or +3 oxidation state, and they have the presence of pH bonds. While the phosphoric acids, they have either +4 or +5, that is the higher oxidation state, and they have the presence of P double bond O and the POH bonds and not pH bonds. Okay, we do not find pH bonds here in the phosphoric acid category. And the parent acid is the orthophosphoric acid. And also one more important prefix to remember is the hypophosphorus or hypophosphoric acid. Hypo prefix means something which is low or under certain value. That means the hypo, whenever we have the prefix hypo in the oxoacids of phosphorus, you have to immediately understand that hypo means the oxidation state has to be lower in that particular category of the phosphorus or phosphoric acid. So hypophosphorus or hypophosphoric acid will always have a low oxidation state as compared to the parent acid. So before we know the structure of all the oxoacids of phosphorus, so these facts have to be kept in mind because that can be a bit overwhelming because we have around 7 to 8 main oxoacids of phosphorus that we study. So before knowing the structure, we have to know a few basic important characteristics of the oxoacids of phosphorus and how to distinguish them. Now let's go back to our question. So here we have hypophosphoric, pyrophosphorus, hypophosphorus and orthophosphoric acid. Okay, we very well know that our main phosphoric acid is the orthophosphoric acid, that is H3PO4. That's the very widely known and widely studied oxoacids of phosphorus. And since it is orthophosphoric acid, so that is the parent that we just discussed, parent acid with a higher oxidation state. Since it is phosphoric, RIC, so it should have +4 or +5 oxidation state and the presence of P double bond O and POH bonds. Okay, so the structure is, you all know. So we have 1 P double bond O and 3 OH bonds. So we have H3PO4. Okay, now from here we can very well calculate the oxidation state. That should be the highest, that should be around 5. So let's check. So let's consider X for phosphorus. Then we have 3 hydrogens. So +1 into 3. +1 is the oxidation state of hydrogen. Then +1 into 3 +3. And then we have -2 oxidation state for oxygen. So we have 4 oxygens, 4 into -2, and the total charge on the acid is 0. So we have X is equal to 8 minus 3, that is 5. So 5 oxidation state for phosphoric, orthophosphoric acid. And how many number of acidic hydrogens? Acidic hydrogen means those hydrogens that can be donated as acids. Okay, as you all know that acids donate protons. So how many protons can be donated from orthophosphoric acid? So all of those protons which are in the form of OH, OH, OH. So we have 1, 2 and 3. So we have 3 number of acidic hydrogens. So the oxidation state is 5 and 3 number of acidic hydrogens for orthophosphoric acid. Okay, then we move on to hypophosphoric acid. First of all, we should attempt those which we know very well. We know orthophosphoric acid very well. H3PO4 we know orthophosphoric acid, and it is one of the options. Option number D. Option number D has 5 oxidation state and 3 number of acidic hydrogens. So 5 oxidation state means D corresponds to P, which has 5, okay, and D also corresponds to 2, which has 3 number of acidic hydrogens. So DP2. So one of the options should have DP2. So let's see if we have DP2. So DP2. The first option has DP2. Rest of the options DP1, DS3, DP1. No, we have DP2 in the first option. So most probably first options should be our correct answer. Okay, now let's check on what next oxoacid we know very well. So the next which we know is hypophosphorus acid. Hypophosphorus acid. So hypophosphorus is C. Okay. Orthophosphorus was D. So hypo we already discussed that hypo should have least oxidation state, and also we choose the phosphorus acid category here first because that only has 2 options, one either +1 or +3 oxidation state. So +3 it is unlikely, so it should be +1, and the formula for hypophosphorus acid is H3PO2. And we also know that phosphorus acid category has a pH bond. So what should be the structure? So H3PO2, we have P double bond O, H, pH and OH, 1 OH. Okay, H3PO2. Now from here we can very easily calculate the oxidation state considering phosphorus as X. We have 3 hydrogens, so +3. We have 2 oxygens, so -2 into 2, -4. Okay, total charge is 0. Okay, so X becomes +1. So we have +1 oxidation state for phosphorus in hypophosphorus acid. And also how many number of acidic hydrogens? Only the OH ones are acidic. So we have only one OH here. So only one acidic hydrogen. So our option C should have oxidation state +1, that is C should correspond to Q, and then number of acidic hydrogen is also 1, so it should correspond to 4. So CQ4 should be the option for C. Okay. Now let's see if option 1 has CQ4. Yes, option 1 has CQ4. So if you have at least out of 4, if you have 2 matching options and you are very sure of that, then you can attempt it and complete your work, because in examinations you have less time. And now for understanding sake and for our learning sake, let's move on to the other 2 remaining oxoacids of phosphorus. So what's remaining? The hypophosphoric acid and the pyrophosphorus acid. Now we have hypophosphoric acid. So hypophosphoric acid has the formula H4P2O6. Now we can see here that we have 2 phosphorus atoms. So phosphoric, so it should contain P double bond O and POH and no pH bonds. So the structure is something like this. Okay, so we have H4P2O6. So 2, 2, 4 and 2, 6. 6 oxygens, 2 phosphorus and 4 hydrogens. Now we can very well calculate the oxidation states. So we have 2x for 2 phosphorus atoms. Then we have 4 hydrogens, so +4. And we have 6 oxygens, so -12 equal to 0. And 2x is 8, so x becomes +4. So +4 is the oxidation state of phosphorus in hypophosphoric acid. And how many acidic hydrogens? Since we have 4 OH groups, so we have 4 hydrogens that can be easily donated. So 4 acidic hydrogens. So number of acidic hydrogen becomes 4. Now coming to the structure of pyrophosphorus acid. So it is phosphorus acid. So it should contain pH bonds. So we have something like this. So we have the 5th oxygen in between the 2 phosphorus atoms for pyrophosphorus acid. And then as usual we have 2 P double bond O, and then we have pH since it's a phosphorus acid, and then the usual OH bonds with phosphorus. So this is how is the structure of pyrophosphorus acid. Now let's quickly calculate the oxidation state. So we have 2x for 2 phosphorus atoms. Then we have 4 hydrogens, so +4. And then we have 5 oxygens. So 5 into 2 -10. Total charge is 0. And then 2x is equal to 6 and x becomes +3. So the oxidation state of phosphorus in pyrophosphorus acid is +3. Okay, now what about the number of acidic hydrogens? So we have only 2 OH groups, so only 2 hydrogens can be donated as acids. So we have 2 acidic hydrogens. So for hypophosphoric acid, we have +4 and number of acidic hydrogen 4. So 4, 4 for hypophosphoric acid. Okay, now let's go back to the question. So hypophosphoric acid, we have 4, 4. So A should correspond to R, which is 4. And again 4, that is 3. Number of acidic hydrogens 4. So that is number 3. So A should correspond with R and 3. AR3. Okay. So AR3 we have in first option. Yes, we have AR3 in the first option as well. Okay. Now what about the pyrophosphorus acid? For pyrophosphorus acid, we have oxidation state +3 and 2 acidic hydrogens. So pyrophosphorus acid B. So that is B. We have +3 oxidation state. So B corresponds to S and 2 acidic hydrogens. That is 1. So BS1. 3 oxidation state for pyrophosphorus acid and 2 number of acidic hydrogens. So BS1. So we have BS1. Yes, we have BS1 also in the first option. So overall, all our oxidation states and the number of acidic hydrogens, they have matched with the corresponding oxoacids of phosphorus, and the option 1 is our correct answer for this question. So I hope you understood the explanation. And before we try to memorize the structure or we learn the structure, we have to keep in mind certain simple characteristics and the basic features that distinguish these oxoacids of phosphorus from one another. And then we apply usual rules for oxidation state calculation and the number of acidic hydrogens. If you have any queries, any doubts regarding any of the videos, please write it in the comment box, and please do not forget to like, share and subscribe if you like my videos. Till then, thank you so much for watching and see you soon.